Okay, here we are on activity 3.2.4. I'm going to get you started on how to do this activity. And it's called beam analysis shortcuts. So what we're going to see is how we can make it easier to do our beam analysis. We did our shear and moment diagrams last time, and as you saw, there was quite a bit of steps to that. So on here, we're going to use both formulas, and I'm going to show you the formulas, and we're going to use a program called MD Solids, which is a very powerful program, and I'm just going to show you how to use it to create the beam and the shear and moment diagrams on MD Solids. So first, here is our problem that we're going to be using for all of our examples farther down. So notice it's up here, the length of the beam is 16 foot, uniform loads are 100 pounds per foot, concentrated loads are 500, and assume distance A is 4 foot. So keep that in mind. Now you'll notice that here they give us what all the variables stand for. You'll also find this on your formula chart. And then the formulas are actually different for each loading condition. Again, these are actually all listed out on your formula chart so that you can put them in. But you have to look up the exact shape that your beam is to find the exact formulas. And if you notice at the top here, it says, note that for this activity, the deflection formulas are provided only for reference because we're not going to calculate deflection. We're just doing shear and moment. So the reaction, to find the reaction, we just take whatever our total loading is divided by 2. So you should check in your calculator that you do get our two reaction forces here are just the load, P, which we know was 500, and divide by 2. That'll give us the reactions here and here. Our maximum moment, remember how we had to do all that before? Well, here all you have to do is take P, which we just saw was 500, times L, which the length was 16 foot, and then divide by 4, and that'll give us our maximum moment. That's all there is to that. So let me show you how to do it on MD Solids. So you should calculate these, write the formulas down on your note, on your activity, and then use MD Solids. So on MD Solids, you should look for a program called MD Solids 40 and open that program. And you can see that there are a lot of different things that it'll do here. What we're doing is beams, so click on Determinate Beams. And we're talking about simple beams. We don't have fixed ends. We have a beam like this, so click there. And it asks you to put in the information, total beam, 16 foot. And I need to change it from inches to feet. And my support is right at 0 on this end, and it's at 16 on this end. So enter. And it draws my beautiful beam here, just like I had it. Now over here you'll see that it gives me different options for loading. Well, I want a concentrated load going down. I'd use this one for a uniform load going down. And you'll see it even has other options we can put. So I'm going to put the load going straight down. Where is it located in the X direction? Well, it's in the middle, so it's 8 foot over. And then it asks me how much is the load, 500. Again, I'm getting this from the top of our activity right there where I had it. Okay, so I've entered that, hit enter. And look at the magic of this program. Here's our shear diagram all drawn out for us, including our reaction forces at both ends. And here's our maximum moment diagram. Is this the maximum moment you got when you calculated the moment with this formula? It should have been. Okay, the instructions say when you get done to print out these diagrams and then attach them to this activity. So that's what you should do. You're going to use the same steps for the other problems in this activity. That's all there is to it. Okay, thanks for watching the video.